Hello viewers and welcome to the new lab. Sorry it's been a while since my last video, but as you can see there has been a few changes. It's taken a lot longer than I wanted, but the lab is getting back into some kind of order now, and I'm really looking forward to making some videos in the new space as it's so much better than the old setup. One other change is from this video I will be using a teleprompter for my script. It will take me a little time to get used to it, and hopefully I won't turn into some wooden statue reading script off the screen. Right, in this video I will be talking about this 27-year-old graphics accelerator card known as a TIGA graphics card. I was certainly aware of TIGA graphics around the early 1990s. The place that I worked at the time was a software company, so I was always reading about stuff like this. But of course I had no need to spend the money and buy something so exotic. So I never had anything like this back in the 90s. These types of accelerator card were reserved for those who really needed specialised hardware and those who had the money to spend on it. So TIGA, or Texas Instruments Graphic Architecture, was a standard created by TI in 1989, essentially to help sales of their graphics accelerators known as GSPs, or Graphics System Processors. TIGA is an API that provides a common interface to graphics cards from different vendors. This means if your software supported TIGA, then it would work with any TIGA graphics card. The TIGA standard requires the use of one of TI's GSPs from the TMS 340 range. These GSPs contain extra instructions and I/O to aid the acceleration of graphics and the generation of the video timing signals. Now TIGA offers by today's standards only basic hardware acceleration with functions like drawing lines, polylines, shapes like rectangles, pies, ellipses, and more advanced functions like blitting and fills. Now TIGA cards were often installed in addition to your existing graphics card, meaning you would likely be running dual monitor, so the accelerated output would have its own display. This is the GXi Lite TIGA graphics card from a number 9 computer. I picked this up off eBay a few months ago. But before we take a closer look at this, I would like to thank my channel sponsor PCBWay for supporting us. Maybe you're interested in building some electronics project yourself? Well, there is a huge range of pre-designed projects available on the PCB website, ready to purchase now. Whether you're a seasoned PCB designer or just a beginner and want to have your own latest design prototyped or mass-produced, then PCBWay have all the manufacturing options you could need, along with great service and fast production. Links to PCBWay will be in the video description. Go and check them out. Now, number 9 was a well-known maker of professional graphics cards in the 80s and 90s. This particular card dates from 1992. Its original price would have been around $600, making it out of the price range of most consumers, but at the lower end of the professional market. It is part of a range of 3 cards. The other 2 models were a little bit more advanced, with the addition of the floating point coprocessor and more RAM. This GXI Lite has a TMS 34020 GSP. It's a 32-bit CPU running at 32 MHz. There is 1 MB of RAM for the program space and 1 MB for the video frame buffer. It also includes a Cirrus Logic VGA chipset that has its own frame buffer, allowing this to be a VGA compatible card as well, making this a single card solution, being both VGA and TIGA compatible. With the 1 MB frame buffer we get 1280 by 1024 in 16 colours, 1024 by 768 in 256 colours, 800 by 600 in 16-bit high colour, 512 by 480 in 24-bit true colour. Thankfully, this did come with the original manual and all but one of the driver discs. The missing one I managed to find elsewhere on the interwebs, so we are able to get this up and running. Now for this task I will be using the 486 machine that I restored a few videos ago with a couple of changes. I will swap the existing Cirrus Logic graphic card for the GXI. I also swapped out the 100 MHz DX4 and replaced it with a DX33. So this will make it a bit more in keeping with the era that the GXI comes from. So I've just removed the existing Cirrus Logic Visa Local Bus card from my 486, and we're going to be plugging in the number 9 GXI Light. And here it is. There is something really nice about plugging cards into your old computer that have ceramic pin grid array processors on them. Oh, I just love that. Anyway, so let's get this in one of the ISA slots. Right, so I have the machine all set up with the card in, and we just need to turn it on and then we can install the video drivers. Now the first thing we need to install is the DOS TIGA drivers. Let's just go into there. Press any key. Drive for the GXI files. C. Directory. Maximum resolution that your monitor can display is 1280 by 1024. Okay, installation is now complete. Reboot. Now we just type GXI. Brilliant, well that's looking pretty good. If the image looks okay, press Y. We have a TI demo. Excellent. Right, that looks like it's fine. So what I want to do is install the Windows drivers next. So here we've got a very plain install of Windows 3.1 Windows setup. So this is just running standard VGA at the moment, so that's 640 by 480 in 16 colours. So let's install the TIGA drivers for Windows, which is this disk here. That's fine. So that's all completed successfully. Excellent. So, restart Windows. What I want to do is actually switch this to 640 by 480 because I want to do some benchmarks at that resolution. So, but yeah, it does look pretty good. So I guess this is running resolution exchange. So we are running 1280 by 1024 in 16 colours at the moment. So what I want to do is run 256 colours at 640 by 480, so I can do some benchmarks. Okay, I think I've got this set up to the point where I can actually do my benchmark. I'm going to be using a old benchmark called PC Magazine WinBench. It's just an old benchmark program from the day, so I'm just going to be running this on the TIGA card, which is already installed, and then I will swap over and do the same benchmark on the Cirrus Logic Visa Local Bus card that was in this originally. So we'll see what sort of difference there is between these two cards. Now, one of the other things that I wanted to have a look at was 3D Studio. I read that version 2 did support TIGA graphics, and we have the drivers for it. So what I've done, I've actually managed to get a copy of that from WinWorld PC. Great resource if you're looking for some old software. And I've got it set up, installed, it's running, as you can see here. I've not really done much with this. I don't really know how to use it, only at a basic level. So this is running on standard VGA at the moment. There's no drivers or anything installed. So I think this display here is running as 640 by 480 in 16 colours. Again, standard VGA like we saw on Windows. So yeah, as you can see, I can move the camera around and all that sort of stuff, and stuff like that. So what I'm going to do now is install the TIGA drivers for this, and then we'll come back and we'll see how things are different. So let me just quit out of here, and then we can install the drivers. Right, I've got the installation disk. Incorrect syntax. Usage: install ACAD or what? US microstation. Ah, right. So Autodesk products. So install ACAD. Good old DOS. Okay, that looks like it all installed okay. It's told me to reboot, so we'll do that now. Okay, what I'm going to do now is just change the default video mode, because I've just had it in 640 by 480. If you recall, I set that for the Windows benchmark. So I'm using a TIGA mode. We are going to change the default resolution to let's go with 1024 by 768, 256 colours. We'll see how that looks. Right, so it looks like it's going to be asking me a few questions because I've installed the drivers now. So, does it have a VGA or SVGA board? Yes, it does. Number 9 power pack. Press any key to continue. Configuration file does not exist. This factory defaults. The product will change these defaults. Press any key. Current video mode selected. Number 9 TIGA 2. Well, that's okay, isn't it? I think. Font selection. No. I'm not sure what to select, to be honest, so let's go with the defaults. Materials editor configuration. Change video selections. No. Change current font. No. Will RC Paddy render on a separate screen? Unlikely. No, because we've only got one monitor connected, so default is no. Rendering screen configuration. And these are just going to stay as defaults, I think. Oh, right, there we go. Right, so let's load in same mesh we had before. It definitely feels a bit quicker, and of course we actually are running in 256 colours now, so there must be a definite speed increase. Modify, no, it's cameras, move. Yeah, that is a lot quicker. So overall that seems to work absolutely fine. I wonder whether this might actually be a good idea to roll this into another video, perhaps, to look at 3D Studio in a bit more detail running on this, this graphics card. If you think that's a good idea, let me know in the comments. But for the moment, I'm going to cut it short here and we're going to have a look at the Windows benchmarks, but it's certainly great that we can get this up and running. Let's take a look at the benchmarks that I did. I've put these results into a spreadsheet. I ran the benchmark on the two cards at 640 by 480 in 16, 256 and 16-bit high color modes, and also included the onboard Cirrus Logic VGA chipset which is present on the GXI. This benchmark times each test and gives you a time to complete the test in milliseconds. So I created a sum of all of these tests to give us a general idea of the speed difference. So lower scores are better. We can see the slowest is the onboard GD5401 using the built-in Windows drivers. As I would have expected, this is the built-in VGA chipset on the GXI Light. Both the Cirrus Logic 5428 and the number 9 GXI are way faster throughout the rest of the tests. There are some interesting things to point out though. Firstly, the GD5428 seems to be crippled by 16 colour modes. It's actually faster in 256 colours than it is in 16. Likely it just wasn't optimised for 16 colours. It's a mid-1990s card, and by then many people were running 256 colour modes anyway, so it probably wasn't much of a concern. The performance difference between the 5428 and the GXI is not that great. The 5428 is actually only marginally slower than the GXI. That is if you ignore the poor performance in the 16 colour modes, but the big point here is the price to performance ratio. One of these Cirrus Logic cards in 1995 would have been well under $100. This is only 2 years after the GXI Light card sold for $600. It is also worth pointing out that TIGA graphics didn't last much beyond the mid-1990s, very likely to this issue. Windows was gaining hold and more application developers moved to the Windows platform, allowing Accelerator specifically designed for Windows to move ahead. A larger consumer base pushes prices down and performance goes up. So in all, a very interesting look at what was a fairly short-lived graphics standard. There will be links in the video description if you want to take a look at the benchmark results yourself in a bit more detail. I have also made the number 9 driver discs available on archive.org. Links to them will also be in the description. The drivers seem to be universal between all the number 9 GXI cards, so they may be of use to someone who has a card with no drivers. If you found this video interesting, please give it a good thumbs up. Comments are always welcome in the comments section. Thank you to all my supporters on Patreon and my loyal viewers. I'll see you in the next video. Bye for now.